Hey, this is Eric with 12 String Theory. I am doing a little work on a Blackstar St James, and I haven't seen information on how to bias these things online, so I thought I'd kind of show you what I surmised from looking at the boards. There's three settings for these. There's a 50 watt, a sag, and a 2 watt. I have it in the 50 watt setting right now, just on the clean channel. Now, if you look down at the board, there's a couple of test points here, TP7 and TP8. Now those appear to be where you actually measure for voltage, because they have callouts on the board for 90 millivolts. And after adjusting the bias, I have 90 and 90. Now, just to give you an idea, this has a bias adjustment and a balance adjustment. And there's a couple of LEDs here that if it's if it's not correct, the LEDs will light up. So the balance, for example, you can turn that and turn on an LED, or turn on the other LED if you go too far, kind of like that. So you kind of know you want to be in the middle, approximately. And just to check here, we're still at 90 and 90. Now this right here is your actual bias adjustment on the 50 watt setting. So if you turn it down a little bit, you'll get an LED to turn on eventually to tell you that you're far away from the factory spec. So now we're at 67 and 68, which is actually, the thing was biased incredibly cold when it came in. It was like 20 something millivolts, so I don't know what was going on with that. So anyway, you turn this back up, eventually the light goes off, but you still have to check the value because it's a little bit touchy. So that's 82. Turn it up just a hair more, because when you get to this point, if you breathe on it, it'll move quite a bit. Let me see if I can get this here. Yeah, so that's like 91. 91, so I'd call that good. Now, there's also a low bias setting here. And there's another test point, TP11, right here, that says 60 millivolts. So what it looks like is if you put it to the low setting and you check this one out here, right now it's 60, but I can turn that down and change that value. Because when you have it on the 50 watt setting, the value doesn't change. So I'll put that back up to where it's supposed to be. It's like watching grass grow. Okay. So now we're back here at 60 millivolts. So if I put it back to the 50 watt setting, it's like 93, 92. I might need to turn that down here. It's coming down by itself. It's kind of a thing where I think it has to settle a little bit. But anyway, that's the ballpark values. We're not launching rockets or anything. So the thing to keep in mind is if you put it in the sag position, which is in between, that changes these points. So now it's a pretty significant difference as far as the voltage here. So you don't want to set the bias in the sag position, because whatever it's doing, it's different. Now, if you look here, the plate voltage is still about 462 volts in both of those positions, in all positions actually. So that's not what's actually different. I don't know what the circuitry does in that sag position, but don't set the bias there, because you'll end up with a very, very high bias. So anyway, that's it. If you look at the 90 millivolts That's almost certainly for 2 tubes. I don't have the schematics for this or anything, but they'll generally take a 1 ohm resistor, measure the voltage drop so you can use that as a way of estimating the current flow through the cathode. So at 462 volts and 45 milliamps per tube, that's in the ballpark of 20 watts per tube, which is within the limits, presumably, of these tubes. If it's a 30-watt tube, is usually what they're rated for. So anyway, that's all. Take care. Bye now.